Hi, my name is Craig, and I'm here to do a little bit of a demonstration dealing with pressure. What I've got and what I've done is I went out to my local hardware store and purchased a valve. This is just a simple valve that you'd find in any plumbing department of a major um, hardware retailer. So now the only thing you need to know about the operation of these little valves is if I have it this way, if the valve is perpendicular to the other part of it, this handle, this red handle, then it's closed. To open it, it's in line, and that will allow, when it's in line, it's going to allow air to flow from one side to the other side. And so what I've done here is I've filled up a balloon and I've attached it to one side. Then I attached another balloon that I didn't fill up. And what I want to see is what's going to happen when I open up the valve. Now, I guess my expectation might be, knowing a little bit about equilibrium, that things go from high pressure to low pressure until they're basically the same pressure. My guess and my assumption would be, well, I open up that valve, this balloon's going to shrink, this balloon's going to get bigger, and they're going to be about the same size at the end of it. And that's what I'm going to expect to see. That's what I want to see, whatever. And so without any further ado, let's see what happens. So I go and I twist this valve open, this handle open. Whoop. There's a little bit of air flood in there, but it's certainly, I don't know, doesn't look like it's the same size. It looks like it's a different size. So what's going on here? Are they not in equilibrium? What's going on? So to address this issue, I could maybe speculate. I could think about it. But how could I actually approach it in any kind of scientific way? How can I answer this question? Can I get some quantifiable data, something that would give me some vision, some insight as to what's going on? Well, fortunately, we have things called pressure sensors here at Ava, that PASCO manufactures, wireless pressure sensors. And this is I've got one over here. I've got a couple things. Let me pull it over there. So I've got a wireless pressure sensor. This is one that this is what they look like when we provide them. We provide them with a syringe and a tube and so forth, because there's all kinds of wonderful things you can do with a pressure sensor when you connect it to a contained environment, because then you can have gases produced and all kinds of things. It's a very productive sensor. It's one of those sensors that I think if you've never been involved in sensors, you might not recognize it as something that's useful. But if you have been involved in using sensors, it's usually one of the ones that you consider early on, because there's so many different things you can do with it. In this particular case, what I've done with it is I've literally taken the sensor without anything attached to the end, and I just put it directly into the balloon. And I've got here, these are large, big balloons. They're 24-inch balloons. I purchased it at a party store. And the reason I got a big balloon is because I literally had to pull open the mouth of the balloon and stick the pressure sensor in there. Now, I'm not going to show you doing that because it actually takes a little while, and I don't think it would be very engaging watching me do that for 2 or 3 minutes. And then the trick here is I have to turn the sensor on. So this particular sensor here, that I'm not going to be using, I would just press that button right there, and that would power it on, and then I could connect it to my device. So I think this pressure sensor is already on. I could look through here, and if it was, I could look at an LED light through there and see it flashing if I took the time. I think it's already on. And so what I'm going to do is I'm going to take this balloon. I'm just simply going to blow it up and look at the pressure that's occurring while I'm blowing it up. And to start, I'm going to click on my sensor data here, file, and this is just a fast way of collecting data. So it's not seeing anything. So that suggests to me that I'm wrong. It wasn't actually on. So now I got to go find where that button is, and it's somewhere on this side. I'm going to press it. I think I got it, and we should see it appear. There it is. So we've got the pressure sensor there. And I'm going to click on that. So now it's going to have a connection there. You can see that the pressure sensor is there. It's connected. If I show you this panel there, it tells me I've got right up there, I've got plenty of power. And then on the third panel, I've got these templates that I can use. And I'm just going to use this first template right there. Just going to produce a graph, and it automatically defaults to pressure versus time. So, you know, without spending a lot of time, I'm just going to hit the start button. As such, I'm going to blow. All right, now I'm going to hit stop. I better hit stop because if I go any further, I'm going to get a little bit lightheaded. But as I can see here, and what's kind of interesting, what I think is very interesting, is I was probably maybe expecting to see the pressure going up and up and up as I blow into it. Wouldn't you expect to see the pressure go up? But in fact, I take my first breath, and there you see the hump that's right there, right? I take my first breath, and that's where I got the biggest increase in pressure. And every other breath after that, obviously the balloon is expanding, but the pressure is going down. So, you know, that tells me a little bit of, you know, that's some information. And how can I relate that to what I had witnessed with the balloon not filling up the other side? Why didn't it reach that equilibrium? And I think it's obvious. It's because right here, the pressure was at the highest at that particular point of time when you took that first breath, not when it was the big balloon. So how is it going to, you know, you have more pressure actually going from the smaller balloon you would in the bigger balloon. So that's why it wouldn't hit some equilibrium. And then you get these you know, each breath again, it gets lower and lower and lower, and then it starts to level off. So the balloon is getting bigger, but the pressure does reach at some point some sort of equilibrium. So the other thing I would like to do is, now that I've got that balloon there, I'm going to hit the start button, and I'm going to do another recording. And all I'm going to do here is I'm going to slowly let the air out of my balloon. I want you to take a look at what's happening there. So I slowly let the air out. Okay. And not much is happening. The pressure is fairly consistent. It's going down a little bit, but not a lot. No, it's going back up. It's pretty flat throughout most of that time. And then it looks like it's starting to go up, 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 it's starting to go up. Oh, and it drops off really quickly, and then it stops. And that, I think, is a very interesting inflection point right there. And it wasn't gradual. It was a very, very, very big drop off that's there, which I think is quite interesting. So as a follow-up to this experiment, you could take this balloon. Let me get this back here. All right, I'm not going to do this. You'll have to do this at your school at some point. But I could fill up this balloon with the pressure sensor, put it on that side, and then take another balloon with another pressure sensor and put it on the other side, but don't fill it up. And I have a feeling that they might meet some sort of equilibrium in pressure, or maybe not. I don't know. It's worth investigating. But that will have to wait for another occasion. Okay, thank you very much.